I'm Anil Kumar, and now let us try to understand turning points of a polynomial. Now, in most of the test papers I've seen, this is a common mistake. Students fail to answer this question correctly, and the reason is that the concept is kind of confusing. Therefore, I have two different videos where I will explain you the number of turning points for a polynomial, and I'll also provide you the reason why it is so, right? So let us start with number of turning points for even degree polynomial, right? So what I will do is kind of sketch few even degree functions here, and then we will discuss about it. So let us assume for the time being that we have a leading coefficient, let me say an. So whenever I write an, assume that an is the leading coefficient we're talking about. We say leading coefficient is positive, right? Let us assume leading coefficient is positive, right? And for our case, we know n is even. So when the leading coefficient is positive and n is even, we know the end behavior, right? So end behavior is that right side is up because an is positive. Even means both will face same side, correct? So that is the end behavior, and from here we can always write end behavior is when x approaches negative infinity or when x approaches positive infinity. In both these cases, y approaches positive infinity, correct? So that is the end behavior. Now let us write about the turning points, correct? So if you see parabola is, I should actually also take a function which has no turning points, right? Which is a constant function, right? So one exception to the rule is a constant function. That is to say, if I say fx equals to a number, let us say 0, 1, 2 or anything, right? In that case, constant means this function is going to be a straight line, correct? So straight line is kind of like this, correct? This is a constant function. It really has a variable, but the exponent is 0. Now this function does not have any turning point, so that is an exception to the rule which I'm talking about. And when we are saying even degree function, then what we are trying to say is that the degree is 2, 4, 6, 8, like this, n, right? So that is what we are trying to say, right? So based on that, I'm giving you a description, okay? Not based on this, right? Here you see it is defined the rule of approaching infinity also, correct? It approaches always a fixed point, which is 2, right? So the y is just 2, not all real numbers. So that is an exception to the rule which we are going to discuss, and it's very important and crystal clear for you, I think, at this stage to understand this point. You may write that as a remark in your test papers. Normally teachers overlook it, so when they say even, they forget about constant function. Okay, let's continue. Now when we say that the function is even, we know, let's say positive end behavior, leading coefficient, then the end behavior is that it's moving from positive infinity to positive infinity as the domain changes from negative infinity to positive infinity, correct? So that means if we start from left to right, always when you're looking at a function or a graph of a function, you have to see it from left to right, okay? So as we move from left to right, the function has to move from quadrant 2 to quadrant 1, right? So if you move from here and you have to turn to go to quadrant 1, right? So that means you should have at least one turning point, right? So what we realize is that since we have to go from quadrant 2 to quadrant 1, at least one turning point, right, is required. If you don't turn, and if you just start from here and don't turn, you'll land up here, right, quadrant 3. But the end behavior says you have to land up there, so you have to turn, right? So let me sketch the first graph, which could represent a parabola, for example, right? So let's say we have a function here, it goes here. Since the end behavior is this, you have to turn. Now since you turn, you have at least one turning point, right? So one turning point. Now think about this function turning again. So if it turns again, what happens? It is leading to quadrant 3. But it has to ultimately end up in quadrant 1. So that means it has to turn again, right? It has to turn again. So how many turning points will this have? 1 initially, and then a set of 2. Do you see that? So it has 3 turning points. So it could have 1 turning point, and if it decides to turn, then it has to turn again, right? That means 1 plus 2, which is 3 turning points. Let us assume that there is a higher degree polynomial, right, in which it is turning again. Now, if it turns, as you know, it will point towards quadrant 3. So it has to land up there, so it has to turn again, right? So that leads to all the time set of 2's. So that means what? That means that the possible turning points are how many? At least 1. That is the least, right? Then it could be 3, 5, and so on. Till what? That is the next question. As you see, a parabola, degree 2, it has to turn once, right? If we have degree 4, that means there could be how many zeros, right? If there are degree 2, there are 2 zeros, correct? If I have degree 4, then maximum you can have 4 zeros, right? So let's assume that we have 4 zeros now. In that case, what happens? Maximum number of turning points could be, let us say like this. How many? 1, 2, 3. 1 less than 4. Do you see that? And therefore, the maximum number of turning points is n minus 1. Correct? In fact, n minus 1 is the maximum number of turning points for any polynomial. It could be even or odd. But for even, least number of turning points is 1. It has to turn at least once. But for odd, it moves from 3 to 1. It doesn't have to turn. So least is 0 for odd, right? But remember, possible turning points are 1, 3, 5, like that. If I say 1, 2, n minus 1, if I say 1, 2, n minus 1, then this statement is not correct. It is wrong. Since we cannot have even number of turning points, this is the point which is not very clear to some students, and they always lose marks on this question. So remember that number of turning points for even degree polynomial is always odd number. So we have odd number of turning points from 1 to n minus 1. What I'm trying to say here is the turning points are 1, 3, 5, 7, 2, n minus 1. That is what I'm trying to say. I hope that's absolutely clear now, right? That should really help you. Thank you and all the best. Now let's look into turning points of polynomials and see whether we have really understood the concept or not. Thank you.